This video is on implicit differentiation, which is a little bit different at first, but hopefully by the end of this video you should have a better idea as to what it is and what we use it for. We're basically comparing two styles of differentiation. They're both essentially the same, but let's look at what we've been doing before. This equation here is called an explicit equation, mainly because y is by itself and it's defined in terms of x. So this is called an explicit equation. And we're going to compare this to what's called an implicit equation, which looks more like this, like x squared y minus 4 equals 7y cubed. Yeah, that's an implicit equation. Now, most of the time this thing has some sort of shape. It probably got a graph, there are probably points that solve that equation. But for the most part, I don't really care what that graph looks like. I want to know how to deal with this and how to do things like take the derivative of that, because this is calculus, so we take the derivative of everything. We're going to go ahead and look at this one first, so let's do that. Going to do this a little bit color-coded so that we can see what's going on. So I have y equals 6x cubed minus 2x squared. All the variables are in colors, obviously. And now I'm going to take the derivative with respect to x. Okay, that's important, x. And so doing the derivative, you can take the derivative of both sides of an equation, and that is okay. It's just like adding 7 to both sides. Taking the derivative is similar. You can take the derivative of both sides of the equation, and the result is the same. So on this side of the equation, we have dy dx. And on the other side, well, we just use our rules. So for this one, we're going to bring down the 3. 3 times 6 is 18, so we get 18 times x, subtract 1, so 18x squared. And then, don't forget from that last video, that chain rule, we're going to have a dx dx minus 2. We're going to bring down the 2 here, so 2 times 2 is 4. We're going to have an x to the first, which is just x. And then we're going to multiply again, chain rule times dx dx. Now notice, this is dy dx. Clearly that is not 1 because dy and dx are not the same. However here, again, dy dx is 1. Sorry, dx dx is 1, dx dx is 1 here as well. So those go away, and we got our final answer of dy dx equals 18x squared minus 4x. Just like that. And another way we can write this, just to be a little bit quicker, instead of saying this whole thing, we can simply say y prime. And so that's an explicit derivative. We just use our same boring rules and we get a derivative. Hooray. Implicit differentiation is going to work a little bit differently. When you have to use an implicit implicit derivatives, mainly you're going to look for two things. Basically, the first thing is that you have x's and y's stuck together. So I'm going to look for an xy, that's a y, that are stuck together. Yeah, and another thing that goes along with that is that it's really, really hard to solve for y in this equation, like in terms of x. So if you can't solve for y, or if you're looking at it and it's got x's and y's and are all messed up together, don't freak out. Just think implicit differentiation. The way we're going to do this is the way we did the last problem. So just like here, when we want to find, and often, most likely, these equations will tell you to find y prime, or the derivative dy dx, and then do something with it, like find the equation of a tangent line or something like that. But essentially, finding y prime is our goal here. So we're going to do the same thing we did last time. We're going to take the derivative of both sides with respect to x. So that's, that's there. And same thing over here. We have d dx, like that, of the 7y cubed. And now, let's do this. So the first thing we do is, well, we have the derivative of x squared times y. Look at that. We have a multiplication, and if you think the product rule, you are correct. We have to do a product rule here. So this is going to split up into two things. Remember, the product rule is f prime g plus g prime f. So What do we have? Well, f prime is going to be the derivative of x squared, which is 2x, and don't forget, dx dx, it's got to be there. So that's your f prime. G is just y, and then plus g prime f. So f prime g plus g prime, and g prime here is going to be dy dx, or I encourage you to just skip the dy dx part and just write y prime. So actually no, either way is okay. If you want to write dy dx, great. If you want to write y prime, great, just don't get confused later. So we have g prime, which is dy dx, times x squared. Alright, then we keep going. The derivative of -4 is just 0, because it's a constant, so we forget about it. And then this is going to equal, here we have to do another power rule. So we have 7 times 3, which is 21, and then we have y, and we subtract 1, so it's squared, and then the chain rule, of course, we have to have a dy dx here as well. Okay, because we're not done yet. We still have to take the derivative of that. Just like here, we take the derivative of x with respect to x and get dx dx. Okay, you have to do that step. Now we're going to simplify a little bit. Of course, here's the simplifying step, is that dx dx becomes 1, so we can get rid of it. And we're left with this, 2xy plus, and now I'm going to rewrite this as y prime x squared, like that. And that's going to equal 21y squared times y prime, just like that. Now, be careful, don't combine those. That's not y squared times y to the first. Y prime is the derivative, so you cannot multiply that with the y squared and simplify it. So this is as simplified as it's going to get. But now what we need to do is we need to isolate and solve for the y prime. Because remember, we had to find y prime. That was the whole point of this question. So let's do that. However you want to do this, you can. What I like to do is, alright, we have two terms with a y prime, so I'm going to move everything with a y prime onto that side. So if I rewrite it, and I'm going to drop the colors because it's getting annoying writing them like that. So we have 2xy equals 21y squared times y prime plus y prime times x squared. Now that they're on the same side, I'm going to factor out the y prime. So I get 2xy equals y prime times 21y squared plus x squared. Almost done. Now all I have to do is just divide by 21y squared plus x squared on both sides of the equation, like that. And that's my answer, basically, is y prime equals this fraction. So 2xy divided by 21y squared plus x squared. Just like that. So notice that this is a derivative. This is y prime. And so if we wanted to find y prime at a certain point, we would need to plug in two things, not just an x value, but also a y value, because y shows up in our derivative. That's okay. So whenever you have this kind of problem, you will be able to find x and y. There are two ways to do that. The first way is, in the problem, they'll give you a point. And guess what? There's x and there's y, and you just plug them in. The second way is they might just give you x, and if they give you x, well, how will you find y? Well, the answer is you're going to go back to the original equation, which is here. So look back at the problem statement, and plug in the x value here, and then solve for y. Then solve. And that way you'll get that y value. Then you can come back all the way over here to your derivative and plug it in. So, gets a little mucky sometimes with the details, but it shows up fairly often. Be prepared. Because of its kind of weird nature, implicit differentiation does show up a lot on the AP exam. It's a kind of a favorite. And the reason that it's a favorite is because you're going to forget to use the product rule, and they're going to kind of try to bank on that. So they'll combine x and y together in an implicit differentiation problem because sooner or later they think that you're going to forget to use the product rule on it. Let me explain a problem that I'm talking about that uses this. Let's say we have x plus y equals the sine of x times y, like this. When you see this problem and it says to find y prime, you should immediately think implicit differentiation, mainly because you have an x, y together, getting all buddy-buddy with the sign right there. Well, let's just take the derivative of both sides and see what happens. So the derivative of x is dx dx. The derivative of y is dy dx. And then this is going to equal, okay, well, let's see. Oh, we have to do a chain rule here because we have a function and then a function inside that function. So the derivative of sine is cosine. And if you remember your chain rule, the derivative is cosine and then stuff, right? The stuff inside stays the same, just like an egg. And then you have to multiply by the derivative of the inside. Well, the derivative of the inside, you're going to have to use the product rule because guess what? It's x times y. Please do not forget that the derivative of x times y is not just y. And the reason is y is a function, so you have to use the product rule. So we have dx dx times y plus dy dx times x. Alright, that is basically almost your answer. Let's go ahead and simplify this a little bit. Again, the dx dx becomes 1 here and 1 here as well. And so your final answer looks something like this. 1 plus y prime equals the cosine of x times y times, parentheses, oh gosh, 1y, which is y, plus y prime x. Whew. That's kind of exciting there, isn't it? Okay, hey, on the next slide I'm going to show you how to isolate y prime and get it by itself. First step is we need to get everything with a y prime on one side and everything without a y prime on the other side. That will require us to split this up into two different things, so I'm going to distribute the cosine like that, and then I'm going to keep this on this side, and I'm going to move this term over to that side, and I'm going to move the 1 over to that side. Just like that. My next step again was to factor out the y prime in these two terms. There we go, that's nice and factored. And then that last step was to divide both sides by this stuff here. And when we do that, here's what our final answer will look like. There it is. So these two are going to cancel out, and then we'll be left with y prime equals cosine of xy times y minus 1 divided by 1 minus cosine of xy times x. Doesn't look pretty, but hey, gets the job done. And then from there you could plug in a point to find the actual slope at a given point, etc. We'll do some practice on this in class, so come ready with questions.